Okay, so the last class we started to talk about transformations, and I realized that, and I was going to do a lesson on reflection, but I wanted to back up a little bit. So we're in math world, and so we talk about things mathematically. We use, and so we may talk about how things have application in the real world and what a real life scenario. But the first and foremost, we define all these terms in math world. So I was gonna, so we made it clear. So we talked about today. We're going to talk about all the transformations again. And in the last class, we talked about the first one, which is a translation. And we quickly said we put it on graph paper. That was the idea. And so we saw that if we translate a point, so if we translate point xy over the vector AB, we were saying that the claim last week is that xy, it was the translation of AB meant we moves it A to the right and B up, left to right, or up or down. And we quickly went to the graph paper. We had no problem with that. But then today I was going to talk about rotation, reflections, and I was like, what's our first example of that? And I realized, well, you look in the mirror and you see your reflection in the mirror. But then I was like, there's no point. There's no other you at the other side of the mirror. And what does it mean to actually reflect through a mirror? And I realized we're going to talk in the world of math. So we're going to talk about points. And we're going to be doing things on graph at points and lines and segments and graph paper. So we have last class it was translation, and so the idea is we plotted a point and we shifted it A to the right, up or right or left, B up or down. The next thing we want to talk about is a reflection. Reflection. So what does it mean? So the image. So let's talk about it. The image of P reflected through mirror L is P prime. And what does that look like? So we know what it looks like. So once again, when you look in a mirror and you look at your reflection, there isn't another you on the other side of the mirror, whatever that means. But let's create a mathematical reality. So we have a point P, we have a mirror, which is a line L. It could be a line or a segment. And we know, when we say reflect the point, mathematically, we're going to say it's kind of right here. So, but what's going on mathematically? Well, a point is a reflection so P prime is a reflection through L of P if what? If, think about this, if line L is the perpendicular bisector of segment P prime. Once again, P prime has been reflected through a line if the line or the mirror is the perpendicular bisector of the segment connecting the pre-image and the image. That's the idea. Because I was confused. I'm like, what does that mean? I'm looking at myself in the mirror. What does that mean? It's my mirror image. Well, once again, mathematically, I'll repeat it again because I say things over and over again. A point has been reflected through a mirror if the mirror or the line or the segment array is the perpendicular bisector of the segment of the point and its image. That's the mathematical definition of reflection. okay? And that's the lesson, that's the idea. And so the idea is we're going to ask you to reflect through 3 lines. We're going to ask you to reflect. We're going to ask you to reflect through the line, through the lines, first of all, the x-axis, the y-axis, and most importantly, the line, can you see that? Yeah, the line y equals x. So once again, this is a mathematical reality. So let's take the first case of the x-axis. If we take a point, xy, and we reflect it through the line, the x-axis, we visually know that what should we call this, A? So we know the reflection is down here. We visually can see that. The image is, well, it's x negative y. Once again, the y-axis is the perpendicular bisector. It's the perpendicular bisector of the segment A prime. There's no, once again, it's like going to a wishing pond in the park and looking down, and you see your reflection. You're not there, but mathematically, xy reflected over the x-axis is the point x negative y. Should we try another? Okay, let's try let's try the y-axis. So if we take A and reflect it over the y-axis, we know it's the point here, right? Let's call it A double prime. Okay, what is the, the y-axis is a reflection, a mirror, because it's the perpendicular bisector of the segment A double. And when we reflect over the y-axis, the point, what's the image? Negative x, y. The height hasn't changed, but the x value has changed. Okay, now here's the really cool thing. When we reflect, you like this one, and you need to know this forever and ever. When you reflect, that's not going to work for me at this point. Okay, let's go back. The last thing we need to, let me lower it. I'm going to put it on the same. When you reflect the point xy over the line y equals x, okay, the question is, what is the image? Well, we know it's this point here. Okay, let's call this C. We know it's C prime, right? We know that this is a mirror because of the segments. The mirror is the perpendicular bisector. But the question is, what is that point? Well, I'm going to leave it to you to prove that it's actually yx. When you reflect a point over the line y equals x, you flip the coordinates. And I want you to think about it. I want you to prove that. Okay, so I want you to pause the video. I want you to try to prove that the reflection of xy is through the line y equals x is yx. Okay, let's talk about this. So let's see the proof. So we have our xy axis. We have the line y equals x, and we have the point xy. Okay, so let's think about this. So we have this triangle here. So we know the point is over here. We know that it's a perpendicular bisector, which means this is equal to this. Okay. We know that we can make this triangle here. We can make this triangle here. Okay. So we know that this is perpendicular, and we know this, which means we know that the mirror is the perpendicular bisector. I'm going to draw the points. Let's call this, CD. I'm gonna draw a point to the origin. I'm gonna create two triangles. Well, these two triangles are congruent because of side, angle, side, which means that all these other angles, this is congruent to this, okay? And this angle is congruent to this angle here. Nice. Let's continue. This is kind of cool. This is kind of interesting, right? What else do we know? Well, you know what? I can drop triangles here. Let me look at these triangles over here. Let's see what's going on here. Well, if this, once again, we know it's y equals x, right? So we know that it splits it in half. So this is congruent to this angle here, right? Right. What else do we know? So we have angle. We know that right here, side. Do we know anything else? Well, we have angle, angle, side. Nice. We have two new congruent triangles. What's congruent to what? Well, let's see. We know that what's congruent to this? Well, we know that this is congruent to this, and we know that this side is congruent to this side. Well, let's see. This double is x. That means that this is x. This is y. This is y. That means this coordinate here is y, x. And therefore, that's one way of proving that when you reflect the point xy over the line y equals x, the image is yx. You flip it. Nice. Nice. Let's try a fun example. So, what is the reflection of the point 1, 2 over the line over y equals 7? And x equals 4, and y equals x minus 3. So let's go through these. Take a second to figure these out. So this might take a little work. You don't need to, I wouldn't memorize formulas or anything like that, but just understand what's going on. We're on graph paper now. It's not real world. It's not like looking in a mirror. We're on graph paper. So make a quick sketch. Let's see, we have the point 1, 1, 2. The first thing I'm reflecting is y equals 7. Okay, so I know that my image is over here, right? And I know it's a perpendicular bisector. Let's see, this is 1, 2. The question is, what is the image? And you can count. You're on graph paper, I could count, but the idea is you're 5 away from line 7. Therefore, you better be 5 away up here. So we have 1, 12. Okay, what is the reflection over the line x equals 2? Okay, x equals 4, sorry. So let's draw the line. Should we draw another diagram, or we could do it on the same paper? Can you see it up there? Yeah. So we have the line, you know what? I can't see that, so I'm going to redo it. Let's do it beneath it. So let's see. Let's draw another diagram. We're going to draw the point 1, 2. And the line x equals 4. Here's the mirror. This is the mirror, and it's the perpendicular bisector of the point and its image. Well, I can see that, once again, the point here is 1, 2. What do you think the image is? Well, I know the image it's 3 away from the line x equals 4, so it better be 3 away also on the other side, which means this is 7, 2. Nice. Now here's the challenge. Kids get confused about this, and it's really not going to show up anywhere. It's a little old school, but I like it. Let's see what's going on here. let's see. So sorry. So let's see. We have the line x minus. I believe it was x minus 3. Okay, and the question was 1, 2 over that. Now we know it's kind of like over here. We know that's where the image is because once again, the mirror for a point to be a reflection, the mirror must be the perpendicular bisector. Please remember, we're in math world. We're in math world. We can take it into physics when we talk about optics and mirrors, but we're just defining this in math world. How do I reflect that? Well, if you remember from the last unit, transformations. So you know what? I'm going to shift everything up 3. I'm going to move this entire graph up 3. So if this is the line y equals x minus 3, shift everything up 3. So my new graph is y equals x. That means that point has to go up to 1, 5. Okay? So if the point is 1, 5, where's the image? 5, 1. Now, is that the final answer? No. Now I have to bring everything back down 3. Then shift back down 3. Final answer? 5, -2. Good luck.